Alright, we started 8.3 yesterday. 8.3 is about graphs of functions, and there are actually, you're introduced three basic functions here as well: linear, constant, and quadratic functions. So we will first learn their definition, and we will graph some of them. And also we will take a look at how to find x and y intercepts. What are intercepts and how you find them is what's covered in this section. Alright, we described what linear function, constant function are yesterday. If you have no x, only a constant number on the right side, no variable, we call it a constant function, and its graph is just a horizontal line, the first one on the top left. A linear function is a line as well, but it's either increasing or decreasing line. It's not just horizontal, because you have a slope and you have a variable present on the right side, and its equation is in the form of a number times x plus another number. And I ask you to remember six basic functions which are used in this course and future courses. They are identity function. Its graph is right between x and y. Quadratic function. It's just like a U shape, but technically this shape is called a parabola. Maybe you hear this more than quadratic function. Parabola is the name of the shape. Cubic function. Absolute value function, it's a V shape. Square root function and reciprocal function. We pictured square root function yesterday, and today we are going to take a look at intercepts. Again, we finish this off, and whenever you need to graph any one of these functions, all you need to do is take some sample values and make sure these values are picked from the numbers that makes this function well defined, not undefined. Because when you substitute negative numbers under square root, they are undefined. Don't take negative numbers in your table. However, in x cubed, you can take any numbers possible, because x cubed works with any kind of numbers. Okay? And we are going to make the third definition today, which is called quadratic functions. By the way, we are going to revisit this section in chapter 10. The whole chapter 10 is dedicated for this concept, quadratic functions. They are extremely important. We will repeat this section again in college algebra coming up next semester. So quadratic functions, never forget them. They have wide applications in industry as well. We need to learn them really well. But in this course, I will just check if you know their definition and if you can recognize a quadratic function at first sight. Okay, so quadratic functions are basically, I call them square functions. What makes them called quadratic is this term. So this term is a must. You must have something with a square, not anything higher than a square though. If you have a cube, we don't call it quadratic anymore. So you must have something with a square. So what are the other two leftover items then? These are optional. Sometimes they disappear in the equation. You may or may not see bx and c all the time. They appear sometimes, they don't appear sometimes. Okay, so three terms together is the most often form it shows up in questions. It's a trinomial actually, trinomial, three-term object. But the other two, again, last two are optional. What makes a quadratic function is this thing: x squared, 2x squared, 3x squared. Okay? Alright, quadratic functions basically have two shapes. Either regular parabolic shape, U-shaped, or it's upside down. Okay? Basically, you're looking for one minimum or maximum value. I call this a seed. and there are two branches. Branch 1 going to the left, branch 2 going to the right. Seed and two branches is what a parabola or quadratic function looks like. Whenever you have the number in front, positive number, like 2, 3, positive 2, positive 3, you will obtain this shape. So this shape, U shape, is obtained if A is more than 0. Upside down U shape, inverted to U, is obtained if you have a negative, like minus 1x squared. Okay? So what we learned right now is constant functions, linear functions, and quadratic functions. Do you know the difference between them? Constant has no x, only a number. Linear function has x, but only with single power, no squares or cubes, etc. But the quadratic function has always squared, x squared, present somewhere. Got it? Alright, let's test. Which one below describes the name of this function you observe here? T of x is minus x squared plus 4x plus 3. Should be a 2-second question. What is the right answer here? Quadratic. Do you all agree? Yes. Why? Because main reason is this. I have a something squared and a number in front. We have also bx plus c. Yeah, these are optional, not required. But this makes a standard, all three terms present, quadratic function. Okay? Next. What is this one called? So first, let's go with elimination. Is it quadratic? Do you see anything square? No. Forget this. Is it constant? Do you see only a number, no x? No. So it's either none of these or linear. Linears are number, x, and plus or minus another number. Does it look like that? You may say, well, this is not a number, fraction. No, 4/3 is a fraction number, rational number. It's a number. So this number can be a radical, can be a decimal, can be a fraction, can be negative whole number. Okay? It can be anything pretty much. So no restriction on it. As long as you have x to it, we call it linear. And you have another number, plus or minus, coming in. Yes, the right answer here is linear. Okay, how about this one? Let's go with elimination again. Is it quadratic? Do you see a square? No. Alright, is it linear? Do you have a number times x plus minus another number? I have x and a number, but they are all under a square root. This is no good. No good. Okay, so this voids linearity. How about constant? Now we have an x, of course not. This is none of these. This is called a radical function, called a radical. If you have square roots, any kind of root, it destroys being quadratic, constant, or linearity. So this is a none of these situation. Okay? So some functions doesn't belong to any group. It can be a fourth type. Alright, that was it. We have now 3 basic function types, you know. And what are we going to do with them is, next is, when you graph these functions, they touch x and y several times. They touch, such as quadratic functions, U-shapes, can touch twice. X-axis and once y-axis. A linear function can touch one x-axis, one y-axis. Or other wild functions, cube functions, for example, can go roller coaster and can touch x-axis several times, 3 times, 5 times, 10 times. Okay, so those touching points go with a special name. We call them intercepts. If your function touching y-axis, we call it y-intercept. If your graph is touching x-axis, we call it x-intercept. And the remaining questions 6, 7, and 8, we are going to find out x and y intercepts of basic functions, not too hard functions. But does this mean this process cannot be applied any other functions? No. We learned this once and we apply this into college algebra everywhere. Whenever I ask x and y intercepts of any type of function, you are going to do 2 steps. Okay? So I will apply these 2 steps, read and apply into the first question down here. How do we find x-intercepts? So step 1 is finding x-intercepts. All you need to do is set the equation into 0. Set equation, function equation into 0 and solve for x. Okay? X-intercepts are found by solving this equation set into 0. So what is the equation here? It's 2x minus 8. You take that equation, set it into 0, and solve. What is x? It's 4. Agree? Just add 8 to both sides. 2x is 8. These cancel. Divide by 2. We get x equal 4. So I know my curve touches x-axis at 4. Where is 4? 1, 2, 3, 4. Right here. So mark it. Well, any point on graph paper or xy coordinates must have 2 coordinates. I only know the first one here. We found only x value of it. I wonder what the other one is. So x-intercept must have 2 components. You just found 1. What do you think the second one is? No, you don't have to plug in nothing. It's 0. Why? It's always 0. Why? Because any point on x-axis always have 0. That's the meaning of x-intercept. X-intercepts are on x-axis and they go with y component 0 all the time. Okay? Alright. We found x-intercepts. Any questions on x-intercepts? Alright. Step 2, y-intercepts. I wonder where my graph is going to touch y-intercept. Alright, guess what I'm going to do? This time we are going to set not the entire equation, only x into 0. Okay? And compute y. By the way, okay, this is the equation of the function, right? But for this purpose, finding intercept purposes, switch this g of x into y, please. It's y values. G of x computes you y values. The addresses passengers travels to, we call it y. So call it y. It's much better. And it says set each x into 0 to solve for y. And get y value. Alright, look at this. So easy. Just substitute 0. And what is the answer? -8. Okay, y-intercept, the value you found is for y, so you can use it in the second component. I'm wondering what the first component is. So you're touching y-axis here, -8. So 1, 2, 3, 4, 5, 6, 7, 8. Here is negative 8. I'm curious what the x coordinate of it. You set it into 0 and found it, and it's besides this thing is on y-axis. Anything on y-axis always go with x equals 0. Okay? And technically what you did here is you set, this was g of x, right? You set y into 0 here. This was y, and you set this into 0 and solved. 0 equals 2x minus 8. 0 equals 2x minus 8 to find x-intercept. So here is the story. To find x-intercepts, you guys setting y into 0. In other words, left side into 0. To find y-intercept, we pick the opposite variable x and set it into 0. Alright, we're done with this half of the question. Oh, not that one. This part. We found x and y. What is the second half? Graph this equation. Graph this function, actually. By the way, I want you to name this function. What kind of function is this? If you know what you're dealing with, it's a lot easier to graph it. If you make a prediction, then you're less likely to make a mistake. What kind of function do you see here? Is it a quadratic? Is it a radical? It's a linear. What is the first 4 letters in the word linear? So you expect to get a straight line here. Alright, you already have 2 dots on that line. You already have 2 dots. The regular method requires us to use many points, as many as you wish. You can put -2, -1. If you have a lot of time in your hand, you can do this all weekend. Put any wild numbers you wish and compute this. But do you really, to graph this, do you really need to set up any table here? Are you required? No, we already have 2 dots on the line. A line does not curve things straight. It's gonna go straight through these points. So you can just connect those dots and extend beyond them in the same direction. Connect them and extend, and you're done with the graph. That's it. So sketching, finding x-intercept and y-intercept actually gives us directly the graph of the linear equations. You don't need any extra work because lines are so simple. Okay? Make sense? Let's see what's required in Connect Math. Alright, we found how many x-intercepts? 1 x, 1 y. And as you see, they require both coordinates. It's 4 and 0 for x-intercept. Y is 0, -8. Now we just need to graph this now. Start with -8 y-intercept and +4 didn't say right. Yeah. This is it. That was easy, huh? Okay, we are going to solve a similar question. So we can go, there isn't any new tricks here. We just need to get x and y intercepts and graph this again. Can you tell me what the x-intercept is on top of your mind quickly? We set the left side, y into 0, right? Set g of x or y into 0 means this side is 0 and solve. What is it? X is 8/5. How do we do that again? subtract 8, divide by -5. It's -8, -5, but when you divide two negatives, it makes positive. So x-intercept is 8/5, 0. How about y-intercept? Y-intercept is even easier than this. Set x into 0 in this function. Y, this is again y, alright? Y is -5 times 0 plus 8, which is -5. We're all done. One of each. X-intercept is 8/5, 0. And this is a common mistake. You put here -5 and 0. Where is the mistake here? Yeah, -5 is for y value. Y-intercept has y value non-zero. X value is 0, but not y. It's not? Yeah, that's another mistake. What is it, 8? And we're gonna graph it now. 8/5. You better turn that 8/5 you found here for x-intercept into decimal. What is it in decimal form? Roughly. It's 1.6 because it's easier to find 1.6 here. This is about 1.6. You don't need to be perfect. And y coordinate is 8. I'm a little off. Let's hope it's gonna like it. It liked it. You don't have to be perfect. 8 is actually right here, but system is forgiving, okay? For little mistakes. So far so good. Any questions? Alright, why don't you guys do this on your own? Try this couple minutes. I mean, there is nothing difficult here. Except, yeah, we have a rational number ratio number in front of x. Let's see if you can tackle it. Alright, for x-intercept, we set y, the opposite variable y, or the left side, in other words, into 0. And so, alright, first I need to get rid of 3. That brings us -3 on the left. Now I need to get rid of 5/6 here. I have a 6 in the denominator. I want to first wipe that off by multiplying both sides by 6 and get 3 times 6, -18. Now I have a 5 to get rid of. For this, I divide both sides by 5 and get x as -18/5. So it seems like this is the right answer. For y-intercept, y-intercepts are always easier. We set x into 0 in this equation. Well, if you multiply a ratio by a 0, a rational number by a 0 is 0. I think this is 3, right? 0 plus 3 is 3. Oh, this is correct. Alright, for sketching purposes only, convert this into decimal, please. And it makes -3.6. For sketching purposes, decimals are better than fractions. This is the only time I like them. So sketch one of each x-intercept is minus 18. I wonder if it's gonna like the decimal answer. So I want to test minus 3.6 and 0. Check. It did. Y is 0, 3. Sometimes system doesn't like decimals, only wants fractions. So just beware. And minus 3.6 is a little past minus 3 on the left. Why is it not marking it here? And y coordinate was 3, right? Agree? And that's it. Easy, right? Anything challenging? Any part you don't get it? So again, chapter 3 so far isn't much work. I'm sorry, chapter 8. So I recommend for exam, please restudy chapter 7. I know rational expressions, rational equations, simplifying them is easy to confuse, easy to make mistakes. So focus on chapter 7 and don't forget chapter 6 as well. We have a little bit of material in chapter 6 in the exam as well. Not a little bit, actually 3 sections. So it's something substantial again. You can stay if you want for the remaining part and ask special questions if you have any homework questions. I mean here, if you have any questions you can't figure it out in homework, bring your laptop and or we can work here. But I'm done.